So supposing I have a stock solution and it has a concentration of 572 ppm. So 572 parts per million. It can be any value you like, and the units can be any value you like as well. And I dilute it first by taking 5 ml. So take 5 ml and make it to 50 ml. And you can imagine that happening in a volumetric flask. You put in 5 ml and then you'd make it up to the line. And then you want to dilute that again. So then you take 10 ml of that, take 10 ml and make it up to 100 milliliters. Well, how do I figure out what my final concentration is going to be? So I know that it started off, this 5 ml started off having a concentration of 572 parts per million. I diluted it once, took some of that and diluted it again. How do I figure out my final concentration? Well, what we're going to use is we're going to use C1V1 is equal to C2V2. And if you remember, concentration by volume is the amount of material in a solution, or of a solute in solution. So the amount in this 5 ml has to be the same as in that 50 ml because we haven't added any more material, we've just added more solvent. So if we follow this through, our concentration 572 ppm by 5 milliliters is going to be equal to the new concentration here, concentration of this, multiplied by 50 milliliters. So 572 multiplied by 5 divided by 50 is going to be equal to 57.2 ppm. Our ppm are still there and the milliliters are going to cancel out. And that's why it doesn't really matter what units we use in terms of volume as long as they're consistent, because they cancel out. And it doesn't matter what units we use for concentration as long as we're happy that they're the ones we're going to need at the end. So we've done our first dilution and we now know that this 50 ml has a concentration of 57.2 ppm. And then we take that and we take 10 ml of that and we make it up to 100 ml. Well, that's easy to imagine. We take our 50 ml volumetric flask and we pipette carefully, or we pour it into another vessel and we pipette 10 ml from this into a new volumetric flask, and then we make that up to 100 ml. So, same equation again, except that our concentration for this is going to be 57.2. So 57.2 multiplied by 10 ml is going to be equal to our final concentration, which will be C2 again, or we can call it C3 if you want, multiplied by 100 milliliters. And that of course is equal to 5.72 ppm. So that's our final concentration. There is a shorter way of doing this. If you take your original concentration, multiply it by the amount you take, divide it by the amount you make up, multiply it by what you take and divide it by the amount you make it up to, then that's essentially the same as doing this out in 2 steps and gets you to the same answer. Because remember, we're just multiplying and dividing and they are commutative. Doesn't matter what order you do it in as long as you multiply and divide the same things. So divide by what you're making it up to and multiply by how much you take for each dilution in series and you'll get your final concentration every time. Okay, I hope that helps. If you have any questions, post them below or email me or ask on Moodle. That's all for now. Bye.